Hello, I'm Alicia DeVos, and today I'm going to present the paper Toward User-Driven Algorithm Auditing, Investigating User Strategies for Uncovering Harmful Algorithmic Behavior, done with collaborators Aditi Dhabalia, Shen, Kenneth, Holstein, and Motahhare Eslami. Today, I'm first going to provide some background, then I'm going to walk you through our study that investigates user strategies for uncovering harmful algorithmic behaviors that involves a series of think-aloud interviews, diary studies, and workshops. Finally, I'll discuss some future directions for supporting user-driven algorithm auditing. Efforts to detect biased, discriminatory, or otherwise harmful behaviors in algorithms are known as algorithm audits and are typically led by experts such as industry practitioners, researchers, activists, or government agencies. However, these expert-led algorithm audits have limitations. For one, algorithm audits often fail to anticipate harms and biases that only arise or may only be recognized as harmful when a system is used in the presence of particular real-world social or cultural dynamics. Another issue can arise if those involved lack the relevant cultural background and lived experience to notice harmful behaviors or know where to look for them. Lastly, new issues can emerge as a result of changing norms and practices around the use of algorithmic systems over time. However, in recent years, we've seen an interesting phenomenon appear as a way to overcome these limitations. There have been a number of cases in which everyday users detected, investigated, and raised awareness about potential issues in algorithmic systems where experts failed to do so. Images of some of the cases that received news coverage are shown here. This behavior has been described as everyday algorithm auditing, a term some of us coined and defined as the ways everyday users detect, understand, and/or interrogate problematic machine behaviors via their day-to-day interactions with algorithmic systems. Though this past work helped us to characterize the lifetime and dynamics that these everyday algorithm audits have historically followed, and to begin to understand why some audits might have succeeded in having impact where others failed, we still don't know much about how people actually go about searching for and making sense of harmful algorithmic behavior, let alone how they are sometimes able to be so effective. We need to better understand this in order to better support user-driven algorithm auditing and increase its potential for mitigating harmful algorithm behaviors. Now I'll present our work toward this goal. This work investigates the question, how do people find, make sense of, and evaluate potentially harmful algorithmic behavior? To investigate this question, we ran a three-phase study with a diverse set of 23 participants. We first conducted think-aloud interviews that provided an opportunity to closely observe participants' thought processes and ask clarifying questions in a relatively controlled setting. In these, participants actively searched for and made sense of potentially harmful algorithmic behaviors in the Google Images search engine. They were tasked with evaluating image searches that are known to potentially contain bias, as well as looking for new cases where image search might be biased. Next, participants took part in 14-day diary studies to complement the interview's live observations by enabling observation of participants' search and sense-making strategies in a more naturalistic setting and more longitudinally, which allowed for the possibility of chance encounters with algorithmic systems. In this, participants documented and reported potentially harmful algorithmic behaviors that they found through active searching or during the course of their day-to-day interactions with algorithmic systems. Finally, since user-driven audits frequently consist of many users, we invited participants who completed the Think Aloud interview and diary study to participate in group workshop sessions. In these, participants worked together to evaluate and discuss some of the cases that were uncovered during the preceding diary study. Participants showed great ability to detect and reason about potentially harmful algorithmic bias in both specific tasks where the research team anticipated bias might be found, and in less prescriptive searches where participants directed their own investigations or stumbled upon bias in their everyday activities. For example, diary study participants submitted a total of 160 reports of potential issues, which spanned areas including gender, sexual orientation, race and ethnicity, socioeconomic class, body type, disability, religion, politics, and combinations of these. This image shows one example case submitted by a diary study participant who searched for images of romantic couples and noticed the results lacked biracial couples, older couples, and same-sex couples. To analyze the data collected, we conducted bottom-up open coding, a series of interpretation sessions, and a thematic analysis of our codes, from which we synthesized a process model to understand how people surface biased and harmful algorithmic behaviors. Our process model captures the process by which people find and make sense of biased and harmful algorithmic behaviors, as well as significant influences on the different stages of this process. In our open coding, three connected high-level stages of people's bias search and sense-making process emerged: search inspiration, sense-making, and remediation. Larger arrows here represent movement between these stages of the process. Connected to each stage, we uncovered two common influences on the process across participants: knowledge and beliefs, shown here on the left, and platform affordances on the right. Smaller arrows represent interactions between the process stages in the middle and the process influences. Due to lack of time, I'm not going to be able to talk about each of the many things participants brought up, but I encourage you to check out the paper for a lot of rich details and examples for each part of this process model. Our process model for users' bias search and sense-making strategies can inform the design of new interventions to facilitate future user-driven audits. Now I'll discuss some opportunities this presents for future work to help us understand how we can effectively support and make use of user-driven auditing behavior in order to overcome the limitations of existing expert-led auditing approaches. This work yielded a number of directions for future research and design. Here are two examples. First, our study suggests that people's exposures and experiences have large influences on the biases they are able to surface. We could assign people particular auditing roles based on their specific exposure and experience to boost future auditing efforts. Also, this indicates that it's important to have auditors with a diverse set of exposures and experiences in order to comprehensively find harmful algorithmic behaviors. We can also leverage our knowledge that platform affordances influence the bias search and sense-making process. For example, we could provide straightforward ways to report bias either to the platform or beyond through the design and mechanism of the platform itself. As another example, we could support comparison on interfaces as a method by which to notice, understand, and evaluate potential bias. Though user-driven auditing has many strengths, it comes with its own challenges and limitations. For one, establishing productive structure and organization is especially difficult amongst large groups of users. Additionally, user-driven audits thus far have been limited to algorithmic systems that are directly visible to users to interact with. A third challenge lies in determining what is noise and what is legitimate relevant information. Weeding out noise includes a level of subjectivity, and apparent noise can actually be an important signal indicating where the ground truth is contested, for example, representing disagreements across different social groups. So now that we've understood user-driven algorithm auditing and how we might support and empower everyday users in their auditing activities, what's next? Informed by the insights gleaned from user-driven algorithm auditing thus far, one valuable avenue for future work centers around designing and developing tools and platforms that support user-driven algorithm auditing. Additionally, a large question lies in determining what it might actually look like to fix the issues revealed by user-driven algorithm auditing. In many cases, there is no clear alignment as to what bias is or as to how to fix the issues. Especially when fixing bias is neither desirable nor possible, promoting awareness of algorithmic biases and other harmful behaviors can be especially valuable. User awareness helps users adapt their behaviors in and around algorithmic systems, in turn fostering user-driven auditing and supporting remediation of harmful issues by other means. Additionally, we need better frameworks to help us understand when to augment and try to fix algorithmic systems versus when to kill and completely remove power from algorithmic systems. Thanks for listening. I'm Alicia DeVos, and you can learn more about user strategies for uncovering harmful algorithmic behavior in our paper.